Yes.
Yeah.
Okay. So the topic for that one is a very interesting topic. So directional well planning optimization. We are not going to talk about just the shape of the well. We are talking about how to make them cost effective. And I think the more important part is about how to make them more deliverable, or let's say smooth for drilling. A lot of these plan shape, they could be complex, they could be building and turning and twisting, but a lot of them are not good for cost. So you can have a shape of the well that looks like a very nice curve and things like that, but when it comes to drilling, a lot of them could be not suitable for drilling. It could be very, very expensive well. So this is something that we'll probably need to not just draw the trajectory, but also to evaluate the trajectory. Evaluate the trajectory for the cost impact, and also the deliverability. How are you going to deliver this shape of the well, which is also very important. You can draw any picture you want. You have to be able to deliver it within the cost, within the kind of expected cost frame. And this is where this kind of expertise comes in, where people who have done this kind of exercise, they have dealt with setback, they have actually solved the problem and improved the cost optimization and make the well the best they could be. So in that domain, when somebody say, I want to do the well planning, a lot of time they actually mean oil and gas well, because this is like 99% of the things in the whole world. People are drilling oil and gas wells straight away, and the geothermal have started to come in more recently. And then we have carbon disposal wells. Those are sort of new in the domain, geothermals and the carbon wells. So we will be focusing a lot on the oil and gas. However, towards the end of this presentation, I would be talking a bit more about the geothermal well. I have been involved with some of the geothermal well planning, and the learning was enormous, because even having all the resources and the smart people on board, we had a lot of trouble that I would like to share some lesson learns about. And the carbon capture wells are unique. Basically, they are the one that are a little bit fancier, because you are trying to get rid of the bad stuff. You are trying to pump the carbon back into the ground. It may be sounding very simple, but it had been quite a bit kind of issues with that one, and placement of the wells for those. I will touch on those as well. So on this topic, I would like to introduce again for myself. I run a small company called Oxford Well Engineering. We are based in London. I've been around for about 22 years, as BA has mentioned about in the introduction. So I'll take you back to my agenda then afterwards. So the introduction for the topic, which we just did actually, so we can touch on it again. Directional well planning optimization. So what are the success factor in this optimization domain? And let me just bring the cursor. If you give me 1 second, please, let me bring in the cursor for us. So yeah. Okay, so it is the kind of factors are more important, and also think about the approach. Whenever a team is going about directional well planning, they want you to optimize the kind of directional profiles and things like that. The important thing is to follow a certain roadmap and approach. Approach should be the one that people have used a lot and that had been successful. You do not want to just go straight to problem solving. You have to do all the checks and balances, which are essential part of finding the right solution. So we will talk something around those lines as well in this presentation. So let's just take it to the next one. So the next one is about the trajectory optimization, the shape of the trajectory. What are the building blocks for those? From looking from top to bottom, for example, the surface location, the subsurface targets, the curves and bends and kickoffs, all these are the building blocks. How would you actually go about optimizing those? There is no kind of straight answer to it. You cannot say that kickoff, use this kickoff, or these are the factors. You have to be smart with it, with each and every part of the trajectory. Consider them as a challenge. Each part has a challenge. And the challenge comes from what you know about the location and the previous wells and the issues that the drilling team has observed. So we will talk about how to optimize the different parts of this trajectory. Okay. And then you go about continuous improvement. If you have been drilling in the area, there may be opportunities that you can actually use to improve your directional well planning, and maybe how to deliver better, basically. Because if you have a plan, your team goes about and deliver it. And how did they do what they have done? Are there any room for improvement? In our business, this is just a little bit of trouble that people say, I delivered it anyway at the end. It took me extra 10 days or 5 days. I delivered it anyway. This kind of answer is okay, but not good enough for people like ambitious people who want to push the envelope. You don't want to be that one who says, I did it anyway in 10 extra days or 20 extra days or whatever, you know. That's not good enough answer. Answer is, yes, let's have a look. Let's look through all the lesson learns and the digital learnings and the information pieces. That could be the best way to do it, to actually continuously improve. If you're not improving, then it is sort of like a dead end street. If you're not looking to improve, it's not going to help you with anything. So this is something like a philosophy that I like to follow. And that philosophy is not bound to this kind of well planning. It could be bound to a lot of other things that you can actually use this philosophy of continuous improvement, which we apply on these, these well planning, exercises and approaches. So let's see what we have other than that. We have some case studies. I would like to bring up some of the very useful case studies that you can probably relate to some of them, because they are quite common situation where people have actually seen these issues. But in that case, there was a happy ending in that one. Like the case studies, unfortunately, some of them were quite expensive because people learn it after they had to pay the price for these things. So we will talk about those few topics. We have very short time, so we will stick to the agenda there. And we will have 15 minutes as, towards the end of the journey, we will talk about geothermal wells. I have put together some slides for each of these areas, geothermal and carbon capture wells. And we will touch on what's different. How would you plan them slightly differently? We'll talk about those and the challenges that comes with it. And then you have 15 minutes available for question and comments, and maybe sharing some of the other information pieces between ourselves. Okay, so let's move on to the next one. Next one is just about myself, as Nikhil has already mentioned. Only thing I would like to add, what Nikhil has said was kind of straightforward, that this is my favorite topic. Directional well planning is my favorite topic, because what I find out by working in-house with very big companies, that we need to do more of these optimization. And whatever we do is actually can reflect very much on the well cost and the deliverability of the actual drilling project. In some companies, people have spent a lot of time in optimizing these. When I moved there first time, I talked to these guys, I was quite surprised. I said, why would we have Rev A, Rev B, all the way to Rev Z of the plan? Why are we keep iterating the trajectories? And they just laughed at me because I was new. And then I realized that at every iteration, they have improved something related to the cost or optimization for deliverability on each iteration. So these kind of iteration, you can do it every day. You can do few of the iterations, but you need to have good reasons. So those iterations can bring you your directional well plan to the best it could be. By the time it is ready to drill, you have done all the optimizations. And that's where the plan should be. If you work for a small company, directional well plan, somebody will draw something at the back of napkin or a piece of paper and tell the planner, go and do this. This is my surface location. This is my target. Hit the target. Very simple. And this guy, this well planner guy, will go and do it. And he say, okay, just move this little bit here and move that little bit there. There you go. It's a final plan. Compare the cost of this well versus the cost done by properly optimized trajectory. You will be surprised. If you have been in the area, you can compare them actually. It's a big difference between the way that the cost comes out. So we need to be very smart with it, because what you can do in the planning phase, you cannot fix it when you are drilling the well. It is too late already. So it's a sort of something that I'm passionate about. I have seen this in action. That's why I wanted to have this webinar to start with. And we can talk a bit more about it as we get along with these slide pack. But this will give you a flavor of what's coming. So let's talk about the kind of approach for well planning team. What actually makes it successful? If you are working in a team, you need to look out for these bits and bobs, these building blocks that should be in place. The first is people. The people you have for well planning team, they need to have right skills, right experience, and more importantly, right attitude. If they have right attitude, they will spend time in learning right skills and build on the experience they have. If you do not have this right attitude in the team, the problem will be very big to solve, basically, because they are not looking to solve it. They are not be so passionate, and they're not be collaborating with each other to solve the problem. Everybody is doing their own thing. So people are really important, but you need to have skills and experience as well. You can have all the right attitude, all the passion, all the drive and everything. If you don't have experience, you would not know where to go. You would not know what will work and what might not work. You will be running in a circle. So you need to have a team. If you are ready to a team, try to maybe align yourself in that kind of mode where you have these skills available, skilled people guiding, but having this right attitude is paramountly important. Having these people, next thing comes in is the process. What kind of roadmap? Do you have the right roadmap for well planning, directional well planning, or anything like designs or whatever, it applies the same thing. What processes in the workflow are you guys following? Are you not leaving things for chances? How diligent you are? Are you covering all the bases of the well planning? Yes or no? If not, right people will fix it. They say, this process is not working for me. I'm not getting what I should be getting in my directional wells. I better improve my process. But who will say that? Only the right people. So process takes second. And if I take you to the next one, that's the technology. Technology is the third thing. Technology is like a toolbox. For me, it's a toolbox. If you do not have a good toolbox, you will be still able to do something. You should be able to solve some problem. Maybe if you don't have a fancy software for directional well planning, you can use Excel sheet if you have Excel sheets. If you don't have Excel sheet, you can use the cheaper softwares. You will be able to solve it if you have good skills, good experience, and you have followed through certain processes. Technology takes a backseat. However, you cannot run the technology, run people. You do not want technology to govern the things. Technology is your tool, and you run the technology as you wish. You don't want to use the technology to just give you an answer. When I studied in the States in the year 2001 and around that time, my professor told me you can train a person and even a monkey to push the buttons in certain ways in a software and plot something and deliver or print out this and do this and calculate the numbers. You can train anyone, a child can do it. So we need to learn how to use this technology efficiently to solve the problem, to serve you and your project not to just for getting an answer or a number that may be spurious. So just to be aware of this philosophy that we need to follow, don't be too much impressed with too much better visualizations and better technology. You don't run, people run technology, people make it successful. Otherwise, technology doesn't do anything for anyone. So this is something that has come back a lot of time. When people have fancy technologies, they still could not solve the problem, and the problem would not go away. So people say, okay, bring in the right people. Let these guys have a say about. Then they use the technology the way it should be. All the technologies are problem-solving technologies. All the visualization don't mean anything if you don't have problem-solving attitude. So this kind of things works best for directional well plans. You will get it right first time. You don't want to drill 10 wells to fix a problem. You want to do it as best as possible the very first time. Use every part of this triangle efficiently to the maximum of its value. Then you can say, okay, let's improve a bit more. So this is the kind of approach I find very strongly about. And I find that people keep forgetting that all these things, maybe I can do the great job because this person has got so much experience, so don't worry about anyone else. That's not true. Okay. So what technology will support team goals, success goals? Let's talk about the cost, okay? Directional well cost had been increasing. For example, directional well cost in the past when I started out in 20 years ago, a slant well, a horizontal well, and all kind of things were quite cheap. I remember I have not heard any daily cost of $1 million. Now I hear $1.5 million for deep water wells. Every day when the rig is drilling, $1 million for a vertical well, 1.5 million, the one for completing the well every day of it. If you are on site for 80 days, that's 80 million straight away, easy answer. And onshore, few years back before the COVID-19, I was involved with a project where the daily cost was $250,000. Onshore well, horizontal well, no surprises at all because they've been drilling in the area for last 25 years. They figured everything out. It's the same shape, same everything. $250,000 for a day when the rig is drilling. It's called burn rate, by the way. Why? And then I checked them recently. I say, what's going on with the wells? The gentleman told me $350,000, gone up by 30%. Same well, same shape, horizontal or whatever those were. Why it is escalating like this? Even though some wells are similar wells, some wells are less challenging. But overall, if you see the big picture around the world is going the same, but for different reasons. There are a lot of things in the mix. And believe me or not on that one, there are so many factors. Some wells are expensive for one reason. Some wells are expensive because of the combination of the reasons. Let's touch on those reasons to see which one applies to some of us. The wells are getting more complex, which makes sense because we already have drilled simpler shapes of the well. We already have drilled these thousands and hundreds of thousands of wells around the world. Easy ones are already drilled. Complex shape means high cost. Complex shales mean you need special technologies, directional drilling technologies, and the problem that comes with hole cleaning, turning and twisting and everything that comes with the complex trajectory. You have to design those complex trajectory. Why would you do that? Because you need to get to the oil. You need to get to the money, and no question asked. People say, get me there and produce oil for me. I don't care how much it's going to cost. I was on one of the well where somebody had a lot of failures. The cost of the well has gone by 25%, around 80 million. 80 million. And people say, no, don't worry. we will get paid soon. Once we finish it, oil and gas will come and we will pay off everything in 6 months or whatever, At that time, the oil price was high, but it's still high, I believe. So people still go for complex things because they wanted to make money when the oil is still high. Other problem that also have been noted by some of the operators are the supply chain problem. Getting things in, services are costly because of inflation. After the COVID-19 situation, there had been a lot of bottlenecks in the supply and logistics. There's a lot of troubles brewing around the world for logistics at the moment. This could increase the cost. Things that are easy to move between the rigs from the point of manufacturing all the way to the rig and other places have gone up by whatever percentage. And it reflects into the cost. The kind of fancier items you are putting in the complex wells, the harder to get the supply chain working for you. And people have everything available basically. And sometimes they have to buy double the equipments. Sometimes they have expensive parts sitting on their yard. Why? Because they don't want to wait for it. If it breaks, they have a backup. They buy too many. They pay for a lot of other stuff, standbys and things like that. They're afraid that they may not get supply. So let's have double of everything. There was one rig contractor told me they have got double of, so that if something breaks, they don't wait. They have it. So, but you have to pay for it, yeah? So this is the directional well cost problem that also comes in the cost of a generally speaking, a well will be suffering with this. And then you have non-flexibility. Let me just go back to this one. Non-flexibility of experienced drilling team. If you have an experienced drilling team, a lot of time they are not flexible. They don't try newer solution. They have been just using certain solution. They have only list of the things that they know they have used. They don't believe in, some of them don't believe in newer ways of solving the complex problem. You can have simple answer to complex problem, but answer may not be right. This is something that you may have dealt with. I don't know if you have worked in the oil and gas, but this is the most important thing, that people don't even give you a chance to explain the solution or try a new solution. They already have simple things to do, simple ways of dealing with complex problem. The result is catastrophic because they can keep solving the problem. It doesn't get away. Because the problem does not go away by simple wrong answers. Simple wrong answer is not a good answer. You need to find the solution, try it. It could be new thing for you or the team, but you need to try a new thing. So non-flexibility stops you and make your well high cost, basically, making it expensive because people are still doing the old stuff that may have worked for them once. Well, same answers don't mix probably. People need to be agile and flexible to adapt to new ideas and new solutions. There are solutions out there. People use them around the world. I'm not asking that they should use the solution first time. I'm asking that ask for certain kind of solution which may be used elsewhere. People don't bother and say, okay, let's make it expensive. Let's use the expensive solution. So that kind of mentality had been stopping people getting some optimization flowing. Okay. And it take you this here. So not using data. You have got all the drilling data, all the offset data. A lot of people already have an answer in their head. They say, okay, I want to drill the same well as I drilled last year. Exactly the same everything. How about improving it? That well had been, let's say, $25 million well. Can we make it 24 million? Or maybe something better? Can we have a look at further optimization? This is what kind of separates a true professional versus so-called experienced drilling guru, that they do not settle on, say, answer was delivered, okay, good enough. Good enough is not good enough, basically. If you are an optimizer guy, if you are a true engineer, you need to actually sink into the data that you collected. Could you do something better? And same applies to look through your directional plan. Have you optimized them to the maximum? Surface locations are correct or not correct? Surface locations are paramountly important. If you select a surface location and the target, the cost is set. The cost is already set for your well. You already lost something if you did not optimize it, because you will connect it as a trajectory. Surface location is like 1 kilometer away from the target. That surface location could be closer to the target. It could be on the side, it could be in the middle. You may be tight with surface location, so you can experiment with surface location. Same with the target. Targets are not fixed. If you talk to a geologist, one day you talk to him or her, she will tell you, this is the target. This is the best place I want to drill to. This is my target. And you talk to these same person after they have done some seismic analysis or whatever in few months time, they will have entirely different target, different shape, different everything. And when you talk to them after a few more months, they have a different target again. So this is something that we need to be aware of, that ask them that this target is better, or can we move the target? If you move the target, you move the well shape. If you move the surface location and the targets together, a lot of time you can. When you are in the pre-planning stage, when they have not confirmed everything, you can do a lot of things that you cannot do later. During my time, I find people selected surface locations they should not be selecting. And next thing you know, they are in trouble. They already built roads. They already built the pad. 1 million here, 2 million for these, pipelines are there. And somebody paid for it, of course. But anyway, so this is something that is sort of critical to be aware of these things. And okay, I'll take you to the incorrect selection of the drilling technologies. Drilling technologies could include rotary steerable. They have different downhole tools. They are fancier. Some of them are old-fashioned things. You can have a proper selection of these technologies by using SWOT analysis, strength, weakness, opportunity, and threats. What are the negatives? This is threat. Okay. So SWOT analysis you need to do for something expensive. For example, you want to drill this section, you have been using certain technology. For example, you're using mud motor, because somebody say it's very cheap, but you're an engineer. You want to see, okay, are you getting the best? So you need to do this SWOT analysis, strength, weakness, opportunity, and threat. I'll show you some more about with a real example, actually. And poor collaboration, poor checks and balances. When you are drilling, when people are drilling the well, the trajectory is in your hands. The trajectory is in your hand, and now you have to deliver it. You have to make it happen. Are you performing checks and balances? Because when you have checks and balances, you can steer the well in the right direction. You can act on it and move things in the right direction if it is going off the track. Are you doing those? Most people will give it away to the directional drilling team and say, this is big company delivering it for me. They are my service provider. I don't have to look back. That's a wrong way, basically, because this is what exactly caused trouble. So poor collaboration. A lot of time, the drilling people do not talk to the subsurface team properly. Subsurface team do not talk to the drilling team. I was told that some of the operator in some countries, they have them in separate floors so that they do not talk to each other. The result is suboptimal well planning, and the delivery of the well is a little bit crooked. This is something that I did not see in a big operator's offices, but we still have this culture of separating them and not letting them have collaboration. Because when they do collaboration, they will get the trajectory right. Trajectory is not the drilling people's deliverable. It's a collaborative deliverable. Subsurface team has to do all the work. Drilling team will be materializing their ideals by making the well that's easy to drill. So everybody has their say, with importance is on the subsurface team, because if they get their targets wrong, surface locations and things will be, everything will be silly, will be useless. The well will be junked. There's no point drilling the well if it is not hitting the targets, the right targets. And same with the drilling team. If it is too expensive to drill, you cost double the monies, not able to drill it nicely and deliver the well which is not good enough, then everybody pays the price. It's a kind of very big thing, but it is explainable. In good teams, I have seen them working together alongside. I have seen them talking to each other in the meetings and everything. So we need to aim for those. If you don't do it, well will be costly and suboptimal. Let's talk about methodology. What you need to do to get it. Review the offset properly. When you review it for cost. You review it for deliverability, lesson learned, constraint, all the digital data you are looking at. You are actually scanning for opportunities. What you can do differently for your next directional well. And directional well planning process, you can shorten and optimize it. If it's a similar kind of wells, there had only been few problems, you can focus on few problems. You don't have to follow each and everything one by one and follow just blindly the roadmap. You can skip the roadmap and come to the things that needs improvement. Then you can shorten and optimize the time it takes you to get to the right directional well plan. You can apply the methodology you have learned. For example, there had been problem with the kickoff. Building was the problem in certain formation. You can apply this to the other profiles, other wells that you're going to be drilling. You can multiply the solution to the other ones which also can benefit from it in the field. If you are going to be drilling 30 similar kind of wells, 20 similar type of wells, apply the learning to each type in other wells, so that when someone picks it up, they have somewhere to start. They already have semi-optimized plan for each of these wells. Excuse me. Well design selection. Well design is a partner of the trajectory. The trajectory and well design, they go together. If you have a very nice trajectory and very bad well design means the tubulars, the way you will be doing the drilling and the technology, the mud system and everything, and BHAs and the pipes. Nothing works. You need to work them together. So you need to look at the well design and put your trajectory fits nicely. Ensure that they go together nicely without any issues. And when I take you to the other one, which is a deeper concept, maybe doing all kind of deeper analysis for your well, including the trajectory itself. You can look for anti-collisions. You can look for how to improve maybe surface location just a bit and some other issues that you have seen. You can improve it in this kind of phase. So these are the sort of directional way of doing it. Start from the basic, going deeper into the analysis, and the deeper as you go. And at the end of the journey, you want to deliver it with optimization, with tightly controlled directional drilling execution. And the last one, you should be able to correct the problem when you are drilling. If you are not getting, for example, the buildup rate, don't worry about it because you cannot do it. Mother Nature is not helping you. You can have a plan to correct it. You can say, okay, I will do this in a tangent, or I will build it later, or I will kick off next time. I will kick off deeper so I don't have to fight with certain issues. So you can correct the course when you are drilling. When you are still delivering the well, you should be able to act on it. You could not do it if you do not have tightly controlled system going for you. It's real-time monitoring, real-time directional improvement and corrections that you need to do. It's everything is driven by the data. If you know you're going off from the plan, system should be able to tell you. That's easy. There's no excuse for not doing this control because the data can actually tell you straight away and the room for improvement. Surface optimization, which I have mentioned, is very, very critical. If you get the surface location wrong, your well is going to be longer, complicated, which should not be the case. You should do all these iterations. For example, in this picture, suppose you want to get to this rectangular reservoir. You have so many options. One from the existing well. Somebody said, okay, let's drill a sidetrack. Another person say, okay, A is a very nice location. I got things ready for this one. They had been a useful place. B is my other choice. And someone say, okay, this D and C are actually, one of them could be the better option. So you could have those options. Then you do this analysis and find out what is the repercussion for drilling a longer well, which is building and turning. What is the repercussion and the cost impact for having a sidetrack from an existing well? And how about C? How about D? If you're onshore, other factors also come in. Some land positions are not available. Some land places are no-go for other people. There are schools and the reservoirs of water or something. So you need to do all these things and find the one that is highly cost-effective, have less risk. For example, if you pick up this existing well sidetrack, it sounds like a good idea. I can drill only these extra maybe section. I can hit the reservoir in no time. How about this existing well? Is it good enough? Is it suffering from well integrity problem? Does it have a life remaining in it? Can you use it for the next 25 years? You have to answer those questions. So it's not so simple that this is shorter, I will take it. This is a straighter, I will take it. You need to do multidimensional kind of analysis, looking through a lot of information. Fit for purpose, cost effective, field-based well planning and optimization. You want to optimize the whole drilling campaign and place the well correctly so that it delivers the production. Collaborative well planning, get with the subsurface team, work with them collaboratively. Don't just do it in a silo because whatever you do doesn't matter. Subsurface needs to stamp it, approve it, and like it. So you need to do the collaborative well planning at every moment. Drillability analysis, you have created the trajectory. Are they easy to drill? Are they good enough to drill? So you can actually check on them and see which one is better for drilling. And you can also design the pads using your knowledge with it. Top hole anti-collision, if you got so many wells coming from the same slot, the same pad, onshore, offshore, sometimes they are only 2 or 3 meters away from each other. Top hole anti-collision planning is the very big thing in offshore environment. Correct selection of drilling technologies, which I mentioned. Some of them are quite cheap, some of them are quite expensive. And then it comes to this one, the constituents, like the building block of your profile. Kickoff point. Where do I need to put my kickoff point? What governs it? There's a lot of engineering model people do, and people choose the kickoff point, which is making it easy, foolproof way. Foolproof means sometimes you fail to kick off. Then what you're going to do? You have to make the dog legs bigger. That's sort of very bad idea, because if you make the dog leg bigger, there could be a problem running the casing. All kind of bad things happen if you do not get the kickoff point right. Build-up rate, dog leg severity needs to be smooth and in certain ways. Sometimes you need a big dog leg. If you need a big dog leg, what else can you do? Selection of technology may be the better option. If you select some technology that gives you the dog leg, but after you have delivered it, you cannot run the casing, or you have problem running things in, and you can get stuck. So it's a very, very powerful thing. Each of these points, which I have quoted, the build section, the hold section, is carefully actually arrived at. From where to where I need to hold, from where to where I need to build, what inclination do I need to build, what dogleg I need to build, what technology I have to have. And all these things need to work together. The drop section, if you happen to have a drop section is a big thing for big tools like 9.5-inch tool. They do not have these technical limits. If you want to drop for 2 degrees, 3 degrees, some of them cannot drop it. If you try to drop them, you can break the connection. This is engineering we are talking about. And same thing with the horizontal well. You need to land it. You need to be smart with it because you need to land it at a certain point. If you get it wrong and get it horizontal, it could be above the target, below the target, then you did not hit the target. Then you have to sidetrack to get to the target. That goes into the cost. Very massive cost, actually. You have to re-drill the whole section or whatever, you know. So those things you need to be aware of, and that can be a big thing on the drill cost. I noted that I got a little bit tight with the time, so I'm going to speed up just a bit. So types of lesson you want to transfer. If you don't do it, it's going to be costly if you don't do it. Anti-collision problems, you don't sort them out, you can be in a big problem because you have to, you can lose the whole well, 25 million or 100 million, whatever that are. Anti-collision problem is big no. Lesson learned about them. If you're coming close to any anti-collision problem, you better know everything by making the plan fit nicely so you don't get to see it again. Bits and directional build-up problems. You don't want to have a certain dogleg in your plan that's difficult to achieve. Okay. Wellbore stability problem in certain formation. For those one, you don't want to build through them. You want to change your plan. You can say, okay, this is my plan. I don't want to do the directional work because this is the wellbore stability problem through certain formation. So you don't do those build in those formation if you have these issues. Same about the kickoff point, which I mentioned. Sometimes it's difficult to kick off in certain formation. Wellbore placement, sometimes you did not place the well right. You should know what did you do and why you need to improve and what could be the solution for your next set of wells. Cutting transportations, contact forces. Contact forces and casing wear is a well integrity problem. So you want to be on the top of it by learning about it. Do you need to drill 17.5-inch or 16-inch? 16-inch is easier to build angle compared to 17.5-inch, but there is a reason why you want to have 17.5-inch. Sometimes it's difficult to run casing in 16-inch. 17.5-inch could be a better option. So we need to measure these pros and cons for everything. Difficulties running wireline, what you need to do. If you must run wireline, you cannot run it. There's no point drilling. Wellbore quality, tortuosity problems. So you can also find out what was the problem with it. So you can go for choosing between the motor and the RSS and the different type of bits, borehole assemblies, the whip stocks, all these things. You can choose the one that is best by putting yourself forward with SWOT, strength, weakness, opportunity, threat analysis, putting what would you like to deliver and what options do you have, putting in the risk factor, putting the money on it, how much money is going to cost you and the time. Then you can narrow into the option that gives you best of the both world with the minimum risks, achieving everything. For example, in this kind of hypothetical case, it's not hypothetical, it's a real case from somewhere, but I made it anonymized. So you can choose one of them, all green, most of them green, and some risks are quoted, explain, can you deal with the risk? Yes. Do you have a mitigation plan? Yes or no. Then you have a winner. You can say, okay, I'll go with this one. And then you have a starting point. Then you have a number two. Option number two could be this guy, could be that guy. So you have three options out of it. You put everything on the table. The criteria, the risk profile, the option you have in the selection of technology, selection of the option you already have. So this is just a picture of if you see a well, you draw the well trajectory, you go from top to bottom, and you look for the things that could be a problem. that you need to incorporate in your directional well plan. This kind of risk review is a kind of estimated number, the very first pass you do. Then you start to go about simulation. You can say, okay, is 17.5 inch is a problem for hole cleaning? Yes or no? Let's do the simulation. Let's check out the buildup rate in the offset well. Let's find out if directionally challenging for the large hole size. Let's check on those. So those are the first question that comes up when you have a trajectory on your hands. Yeah, this is the well from North Sea, by the way. Importance of checks and balances. This is just a case study I wanted to share. In this case study, somebody forgot to put in RKB elevation. It should be 5. Somebody put it 7. Because of that, they could not find the horizontal bed. When they tried to land it, they could not hit it. They were just 2 meters above it because their survey system had a mistake. The survey was saying that you are 2 meters deeper, but you were 2 meters shallower from reality. They could not find it. They tried, they check on this and that. They have to pull out of the hole. When they checked it, it's a simple fix. They have to say RKB was 5 meters. They were thinking they were 2 meters deeper, but they were 2 meters shallower, actually. When they fix that, they know they were shallow. All they have to do is to drop it into the reservoir bed. So those things are very silly mistakes. Checks and balances are very big thing, especially when it comes to evaluating the position of your targets against if you're penetrating them or not. People do those mistakes, by the way, a lot of times. And same with the situation, if you have the wrong surface location, the wells could be very complicated. If you optimize the location, it's a very quick picture that's showing you the wells that had become turning and twisting. If you change the surface location, they can become shorter. They can be having less turn and twist. This is just a quick picture. And now we will just touch on some of the geothermal wells and the carbon capture wells, some of the basics about them. I will be very quick with them. For oil and gas, it's kind of very straightforward. We already know about them. Geothermal well, they are very special. Basically, they require a certain different profile. You don't want to have complicated ups and down and turn and twist. Also, you cannot have a lot of directional work done in the hot temperature. Most of the time, they cannot use expensive high temperature tool. So they have to do all the directional work before they hit the target. It will be done upstairs, and the rest of it could be tangent. Large borehole sizes, it's not easy to build angle. They use the basic LWD technology. Also, their well design is very complex because they have high temperature environment, high failure rate, by the way. If I show you the picture, this circle is telling you how the geothermal wells compare to the oil and gas well. The geothermal wells took very long time, 3-4 times more time drilling the same depth, same shape, because of very hard formation drilling. Very hard formation drilling, stuck pipe. You can see the signature of a stuck pipe. This hump is a stuck pipe. They stuck and they drilled it again. And they got stuck again and drill. These humps are the stuck pipe situation. So they got stuck a lot of time, by the way. So they are different breed, but their directional challenges are not such a big deal. For carbon capture well, you mostly drill vertical well. If you want to drill a brand new well, you always drill a vertical well, because vertical, you can connect various layers of carbon disposal places. You can have one here, dispose carbon into this one, dispose carbon into that one. You can have sliding sleeve, and you can also have repurposing. If you have been drilling previously, you can have a sidetrack going to some other formation and dumping the carbon and pump the carbon into this one. So the trajectories are not so bad looking. You know, it's not so complicated. And the problem with that one is you need to place the well right. If you do not place the well right, you could have escape of CO2. CO2 can escape in the existing well, abandoned well, into the water bodies. This will be a disaster, basically. So the placement of carbon wells are the most important part. You need to have some kind of contingency and risk analysis done for that. And that is the very important thing. It's a critical thing not to, because if you pump the carbon, it's going somewhere else. It's causing the problem for other stuff and natural habitat and everything. So that's the most important part. People can also use fancier technologies like intelligent completion. They can put the intelligent completion in the vertical part, connect all the layers into one, open and close as you like, and pump into whichever you want to pump. So those things could be used. So I think this is my final slide. Sorry, I took just a bit longer, and I will bring back to Nakhil for